This unit in geometry is all about parallel lines, perpendicular lines, and the angles that are formed when you have a parallel set of lines that is crossed by a transversal. We're going to be doing a lot of algebra review in this unit by writing equations of parallel lines, writing equations of perpendicular lines, and a lot of graphing. But this particular section is about parallel lines, identifying them in a picture, identifying perpendicular lines, identifying skew lines, and identifying the angles that are formed when you have two lines cut by a transversal. Parallel lines must be coplanar and they do not intersect. Skew lines are non-coplanar lines that do not intersect. And I know that right now skew lines, they are the new one for this section that people don't know from past knowledge, and they will make more sense when we see them in a picture. But they're not coplanar and they will not intersect. Parallel lines are parallel planes are two planes that do not intersect. And a transversal is a line that intersects two or more coplanar lines at different points. The blue line in this picture right here is a transversal. Here are the types of angle pairs that are formed when you have two lines cut by a transversal. You have corresponding angles. These are formed when you have a transversal that cuts through two lines, and these occupy corresponding positions. So if you see the yellow in this image down here, those are in corresponding places. There are actually 4 pairs of corresponding angles in this picture. The green highlight is the alternate interior angles. They are in between the two lines and on alternating sides of the transversal. There are 2 pairs of these. Here is one in green. The alternate exterior angles has 2 pairs as well. They are on the outside of these 2 lines. Instead of in between them, they're outside of them. And they are on alternating sides of the transversal as well. So one is over here on the left of the transversal, and one is down here on the right of the transversal. Consecutive interior angles are also called same side interior angles. And these are on the inside, so between the 2 lines, and on the same side of the transversal. So these are in this picture here with these little dots. They're both on the left and they're both inside. The other pair would be on the right side here. This green one and this yellow one would also be consecutive interior angles or same side interior angles. Here we have a couple of theorems, pretty obvious, or a couple of postulates, pretty obvious postulates here. If there is a line and a point not on the line, then there is exactly one line through the point that is parallel to the given line. And if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. Here we have some sample problems where we're going to identify parallel lines, perpendicular lines, and skew lines. In this image, around the outside here, we need to, they don't have it marked, but I do want us to realize that these are right angles in the corners. So, and then on the other parts around it as well. So it says find a line parallel to line MN. Oh, and also each segment in this image represents part of a line. So find a line parallel to MN that contains J. So here's J, and we want to be parallel to MN. If we're going to be parallel to MN and contain J, then we need to be the line JL. So name in, remember, 2 capitals with the line bar over the top. Gotta name it correctly or we wouldn't get credit. The second one says find a line skew to MN that contains O. Skew to MN that contains O. So here's point O back here. And to be skew means that it's not going to touch the line, but it is also not going to be parallel to it. So we're going to look for a line that doesn't go the same direction, but also will not intersect with MN, which I just put the green line on MN there. So if I need to go through O and I cannot touch this, then I'm going to go this direction, because those are going different directions. They're never going to touch, but they're also not parallel. That's important when you're identifying skew lines. You don't want to pick parallel lines, but they also have to be where they will never touch. So that's line KO or OK with my line symbol over the top. Find a line that appears perpendicular to MN that contains L. If we want to be perpendicular to MN and contain L, and I'm glad they put appears because that was what I was talking about, we're going to kind of go with these being right angles. To be perpendicular to MN and go through L, it's going to be this ML right there. So ML, naming it with our line bar there. Name the plane that contains K and appears to be parallel to plane MNO. Plane MNO is the back part there, that little back triangle, and if we want to be parallel to it, I would say it's this front figure. Kind of block my letter there. I'm going to call it JKL. And remember, when you name a plane, you have to put plane in front. Plane JKL. Here's another image. Think of each segment in the figure as part of a line. Name a line parallel to AF. So AF is the top part of the figure. If I'm going around the sides of the figure here, each of these segments would be parallel to it. EJ, DI, CG, BH, any of those. It says just to name one, and it says to go through E. So if we want to go through E and be parallel to that, we're going to be line EJ. Always watch for if they tell you what letter to choose to use in your naming. Name a line skew to AF. So AF again is this top part here. We do not want to be parallel to it. We want to be skew. So we cannot touch it and we have to go in a different direction. They said to be sure and include point J. So if I said EJ, that's parallel, that's not going to work. If I said FJ, that would intersect it and that would not work either. So I'm going to use IJ. So line IJ there, capital I. Name a line that appears to be perpendicular to AF containing the point B. So there's AF there, here's point B. These appear to be rectangles around the sides here, so I'm going to go with BA to be perpendicular there. Because where they are meeting, I believe it would be a right angle, kind of like this looks like a right angle. Name a plane parallel to plane FGH. FGH is the back part of the figure there. So if we're going to be a parallel plane to this, then it would be the front part of the figure. The bases of a prism like this are parallel. So I'm going to say plane, and you just choose 3 letters in the front of this. I'm going to call it plane BAE. Plane Bay there. All right, let's see. Right here, using the given figure, name a pair of parallel lines. When you see a figure like this, there's markings that tell you that lines are parallel. Those are these little arrow markings. Be on the lookout for those markings to know that they mean that they're parallel. So naming my lines, A, B, the bar over the top with the arrows, is parallel symbol right here, kind of slanted, couple of L's there. CD is the other one. Then they want perpendicular. Remember that the symbol for perpendicular is this right angle box here. So it's going to be line AB and line AC. And the perpendicular symbol is this upside down capital T marking like they have over there in this question. So we said it was AB perpendicular to AC. All right, and then they're asking, is AC perpendicular to CD? Well, if AB is parallel to CD, then they will end up being perpendicular to AC. If one is perpendicular, the other will end up being that way, because we already know about slopes. The slopes of parallel lines are the same, and the slopes of perpendicular lines are opposite reciprocals. So if this AC is an opposite reciprocal of AB, then CD and AC will also have those same relationship. So yes, AC will be perpendicular to CD. It's something we will know more later, even though they didn't have the marking in this picture.